Okay, so this video is going to be an overview, review, refresher of exponents. So we're going to go through all the basic exponential manipulations, common errors. It's not meant to teach you exponents from scratch. Okay, so the first thing I want to do is just quickly go over what an exponent actually is. So an exponent is something multiplied by itself. So 2 to the third is 2 times 2 times 2. So you're multiplying 2 by itself 3 times. It's not obviously 2 times 3, which would be 2 added to itself 3 times. And the same thing goes obviously for variables like x or y, whatever you have. X raised to the 5th power means you're multiplying x by itself 5 times. You're not adding x. Okay, so now let's get into the basic rules for exponents. So these are the 3 main rules that you're going to need. So when you multiply two variables, let's say x, when you have x to the a and x to the b, you're going to add the exponents together. And that's because, let's say we have x squared and x cubed. That means that we have x times x, so we have x multiplied twice, and then we have x multiplied by itself 3 times. So you can see now we have 5 x's, so that's x to the 5th. And now when we have parentheses, so if we have x to the a and then that whole thing is raised to the power of b, that would be, for another example, if we have x squared and then we raise that whole thing to the power of 3, we would have x times x, and then we would have that 3 times. So we have x times x, x times x, x times x. So now you can see I have 6 x's. Okay, and then our final rule is x to the negative a is 1 over x to the a. Okay, so for example, if I had, let's use a real number here. So if I had 2 to the negative 2, that would be 1 over 2 squared, which is 1/4. Okay, so these are the 3 main rules. And now there are 2 more rules. So these are the 3 that we just saw. These are like the 3 main ones. And now this one, you can kind of, it's just a combination of this first rule and this third rule, because if we have x to the a over x to the b, we know that x to the b in the denominator like that, we can just write it as x to the negative b. So we're using this rule here. And then if we have x to the a and x to the negative b, that's just x to the a plus negative b. So we just have x to the a minus b, which is basically just this rule. So this rule is just a combination of these 2. And then we have this rule where x to the 1 over a will just be that root. So if we have, let's say, 4 to the 1/2, that's just equal to the square root of 4, which is 2. If we have, let's say, 8 to the 1/3, that would be the cube root of 8, which also happens to be 2, and so on. So you can do, any root you can write as a fractional power. Okay, and then we have 2 sort of special cases. So anything raised to the 0 power is 1. So like 3 raised to the 0, x to the 0, a to the 0, 42 to the 0, all of those are going to be equal to 1. So anything raised to the 0 power is 1. Now, you might see in some books, it'll say as long as the thing you're raising to the power of 0 is not 0. So as long as a is not equal to 0, then it's equal to 1. That's because 0 to the 0 is undefined. Some books you might see will define it as 1, but that's sort of like a little bit of a controversy. So we're not going to get into that in this video, but we'll just leave it as undefined. And, in an intro level course, you're never going to really see 0 to the 0 anyway. Okay, and then any number raised to the power of 1 is itself again. So 4 to the power of 1 is 4. 0 to the power of 1 is 0. Anything. So, okay. All right, so let's do some examples with just positive exponents for now. Okay, so a squared times a to the 4th, that's just going to be a to the 2 plus 4, which is a to the 6th. Then we have a to the 2, and then that whole thing raised to the 4th. So that will be a to the 2 times 4, which is a to the 8th. Then we have a to the 4 over a to the 2. So that's a to the 4 minus 2, which is a squared. Then we have b squared and then cubed, that whole thing cubed. So that will just be b to the 6th because we multiplied 2 and 3. B to the 1 times b to the 4th is just b to the 5th, 1 plus 4. B to the 0 times b squared. Now remember, b to the 0 is 1. So this could be like 1 times b squared is just b squared again. Or you could think of it as b to the 0 plus 2, which would still just be b squared. Then we have x to the 1 times x to the 1. So that's x to the 1 plus 1 is x squared. X to the 4 raised to the power of 1 is just going to be x to the 4. X to the 3, and then that raised to the power of 0 is going to be just 1. So anything, remember, raised to the power of 0 is just 1, even if it's something like x cubed or x to the 4th, whatever, it's still just 1. Then here we have sort of like two rules combined. So we have a to the 4th and a squared. Now, everything in these parentheses are going to get squared. So we're going to have a to the 8th over a to the 4th. So that's going to be a to the 8 minus 4 is a to the 4th. Then the same thing here. Everything inside the parentheses is going to get cubed. So we're going to have a to the 4 times 3, which is 12. And then that's going to be over a to the 3 times 3, which is 9. So that's going to be a to the 12 minus 9 is a cubed. And then finally we have a to the 2 divided by a to the 5. But that whole thing is raised to the power of 0, and anything raised to the power of 0 is just 1. So this whole thing again is just 1. Okay, so then a very common mistake is sort of overlooking parentheses and your exponents. So this first example where we have 3 and then x squared, that's basically just 3 times x squared. So the 3 has nothing to do with the squared here, only whatever x is, x just gets squared, nothing to do with the 3. Then if we have parentheses around both of them, so if we have 3x in parentheses and then squared, both the 3 and the x get squared. So this is equal to 3 squared times x squared, which will give us 9x squared. So this is sort of, like a notation thing to be careful of. If they want you to square the coefficient in front of your variable, they'll always put a parentheses like this. So this always means just the x is squared, and this always means the coefficient is squared or cubed or whatever it is as well. So whenever you see parentheses, everything in the parentheses gets that exponent. Okay, now let's do some examples with negative exponents. So a to the negative 3 is just 1 over a cubed. A squared times a to the negative 1 is going to be a to the 2 minus 1, or you could also think of that as a squared over a to the 1, and that will give us a just to the power of 1, so just a. And then we have a squared times a to the negative 3, so this will give us a squared over a cubed, which is equal to a to the negative 1, or just a 1 over a. All right, then a to the negative 3 times a to the negative 2 will give us a to the negative 5, or just 1 over a to the 5. Usually we like to leave everything with positive exponents if we can, so writing it like this is usually preferable to writing it like this. Okay, then a over a to the negative 1. So I'm going to open up a new page here so we could just go over the algebra for this. So if we have a over a to the negative 1. Now, there's a couple different ways you could do this, obviously. You could say a to the 1, because when we have just a like this, it's a to the 1. So we have a to the 1 minus negative 1, which is a to the 1 plus 1, which is a squared. But another way to think of this is, let's just look at this denominator for a second. So if we have like 1 over a to the negative 1. A to the negative 1, we said, is 1 over a. So this fraction is really like 1 over 1 over a. And 1 over 1 over a is just equal to a. So we can sort of rewrite this a over a to the negative 1 as a times a, because we know that this is just equal to a. So we have a times a, and we know that's just a squared. So that's another way of looking. So that's important to remember for your negative exponents. When you have a negative exponent in the denominator, it's actually in the numerator. Okay, so we said that this was a squared. And so now the same thing for this next one. We have a to the negative 3 and a to the negative 2. So let's just look at this a little bit more carefully. So we have a to the negative 3 over a to the negative 2. Now there's a couple different ways you could look at this. We can say, all right, this is a to the negative 3 minus negative 2, and that will give us a to the negative 3 plus 2, which is a to the negative 1, which is 1 over a. Or we can look at it this way and say, all right, we know that a to the negative 3 is 1 over a to the 3, and we just saw that a to the negative 2 in the denominator is actually a to the 2 in the numerator. So we actually have a squared in the numerator now. And this is equal to a squared divided by a cubed is just a to the 2 minus 3, and that's equal to a to the negative 1 again, or just 1 over a. So whenever you see negative exponents, whether they're in the numerator or denominator, you can basically just flip where it is and make it a positive exponent. So a to the negative 3 over a to the negative 2 is the same as a to the 2 over a to the 3. Okay, so we have 1 over a for that one. Now here we have b to the 3 and then raised to the power of the negative 2. So we have b to the 3 times negative 2. That gives us b to the negative 6, which we can write as 1 over b to the 6th. Now if we have b to the negative 3 raised to the negative 2, that is going to be b to the negative 3 times negative 2, which is just b to the positive 6. Now this next one, we have 2 variables to multiply. So that means that everything in the parentheses is going to get raised to the power of the negative 2. So we have a to the negative 4 times b to the negative 8, and that will just be 1 over a to the 4, b to the 8. So we just have 1 over a to the 4th, and then b to the 8. Okay, now this one, again, we're kind of combining a couple different rules. So everything in the parentheses is going to get raised to the negative 3. So we have x to the negative 6 divided by y to the negative 6. And we said if we have negative exponents, we can sort of just flip whether they're in the numerator or denominator. So this will just become y to the positive 6 over x to the positive 6. Now we have x to the negative 2 over y, all raised to the negative 2. So we have x to the positive 4 from the negative 2 times negative 2. And then we have y to the negative 2 on the bottom. And we know that y to the negative 2 in the denominator is the same as y squared in the numerator. So we just have x to the 4 times y squared. And now this one, we have 2 in front of our x squared. So we're going to have 2 raised to the negative 2 times x to the negative 4. And then we have y to the negative 6. So since all of these exponents are negative, we can just flip the numerator and denominator, and we're going to get y to the 6th on top. And then we're going to have 2 squared on the bottom, x to the 4th on the bottom, and we know that 2 squared is 4, so we just put 4 here. Okay? All right, now another thing to be careful of is, again, with the parentheses, but this time with negative signs. So if you see something where it's like negative 9 squared, this is negative. So negative 9 squared is negative 81 squared. And you can think of that like you're really writing negative 1 times 9 squared. So the square is only applying to the 9 and not to the negative as well. So it's just negative 1 times 9 squared, which would give you negative 1 times 81. So we get just negative 81 for that. So the negative is not getting squared in this case. Now here, where we have the parentheses, your negative is getting squared. So this case would be positive 81 because we know a negative squared is positive. And the same goes for if you had like x or y or a or b instead of a number. So anytime you see like negative x squared like this, you're never also squaring the negative sign. They will always write it with parentheses if they want the negative sign to be included in that square like this. And then let's just look at like negative coefficients for a second. So let's just start with, if I have negative 3 squared, we said that that's positive 9. What if I had negative 3 cubed? Well, now I have negative 3 times negative 3 times negative 3. So that's actually going to give me negative 27, right? Because now I have a negative times a negative, so that's positive, and then I'm multiplying by another negative, so that's negative 27. And so you can see that this will happen basically no matter how big your exponent is. So if I had like negative 3 to the 20, whatever that number is, it's definitely going to be positive. Because if I multiply a negative an even number of times, I'll always get a positive number. And then if I do negative 3 to the, let's say 21, I know whatever that number is, it's going to be negative. Because anytime you multiply a negative an odd number of times, you're going to end up with an overall negative sign. So anytime you have an even exponent, you know you're going to end up with a positive answer. And anytime you have an odd exponent, when you're multiplying a negative number, obviously, you're going to end up with another negative number. And this is true even if your exponent is negative. So if I have, let's say, negative 2 to the negative 2, that's going to give me 1 over negative 2 squared, which is 1/4. And then if I had negative 2 to the negative 3, I would have 1 over negative 2 cubed, which would have that negative sign. So I would still have 1 over negative 8. So the same holds true even if your exponents are negative, your overall answer will still obey this. And obviously the same is true also if we added in some variables. So if I had like negative 3 times x squared, that's going to give me positive 9x squared. If I had negative 3x cubed, that would give me negative 27x cubed. Okay, and then a very common mistake that a lot of students make is writing, when we have a plus b and then squaring that whole thing, is writing it as a squared plus b squared. And this is not correct. The correct answer has this extra term here, and you can kind of figure this out, or you can see this even if you just plugged in numbers. So if we try it with like, let's say 2 plus 3 squared, 2 plus 3 is 5, and 5 squared is 25. So we know that the right answer should be 25. But if you try just writing 2 squared plus 3 squared, well then we end up with 4 plus 9, and that gives us 13, and that's definitely not 25. So you can see that that's not the right way to handle this sort of expression, just by plugging in numbers. Okay, so this is the correct answer, so let's put it over here, and this is the wrong answer. So do not write this, don't do it that way. So remember the correct answer, we have a plus b squared, so that's like multiplying a plus b times a plus b, like this. And if you have something like this, you're going to have to FOIL, right? So you have to do a times a is a squared, and then you're going to have a times b, which is ab, and then you're going to have b times a again. So that's another b times a, and a times b are the same. And then you're going to have b times b, so you have plus b squared. So you can see now that you have a squared plus 2ab plus b squared. So we have two factors of ab there, and then we can see if we plugged in just regular numbers again, so let's plug in 2 and 3, this does give us the right answer. So if we do 2 squared plus 2 times 3 plus 3 squared, that's 4. This is 2 times 2 is 4, times 3 is 12, plus 9. We do get 25. Okay, so this is the correct way to write out something like a plus b squared. All right, now let's just do some like challenge examples, and then that'll be it. All right, so the first thing I would do here is kind of just write everything that goes together. So I would put all my coefficients, and then all my a's, all my b's, all my c's. So we have 4 times -2 out front, and then we have times a squared times a, and then we have b to the -3 times b to the 5th, and then we have c to the 0, which we know is just 1, so we can kind of get rid of that right away. Okay, so 4 times -2 is -8. And then we have a squared times a is going to give us a cubed. And then we have b to the -3 times b to the 5. That's going to be b to the -3 plus 5 is b to the 2. So then we have b squared. And that's it. So we have -8, a cubed, b squared. Now here we have 3 times a times b to the 5 times c to the -1, and then that whole thing is squared. So we're going to have to square everything in the parentheses. So that's going to be 3 squared times a squared times b, and it's going to be 5 times 2, so that's 10, b to the 10. And then we have c to the -1 times 2, so that's going to be c to the -2. Now we can simplify a few things. We know that 3 squared is 9, so we have 9 times a squared times b to the 10, and then we have c to the -2, so that's all over c to the 2, c squared. All right, and now this next one, we have for this next one, we have two terms where this first one is everything is cubed, and this second one, everything is squared. So we're going to have to be very careful with this one. So everything in that first term gets cubed, so we're going to have 2 cubed. A, 2 times 3 is to the 6th. Then we have b, 3 times 3 to the 9. Then we have -a squared times b to the 4 times 2, which is 8. So now here we have -a squared, we said is just a squared because we're squaring that negative sign, so this just becomes a squared. And now we can just add up our a's and b's here. So 2 to the 3, 2 cubed is 8. We have a to the 6, and a squared is going to give us a to the 8. And then we have b to the 9th and b to the 8th. So that's going to give us b to the 9 plus 8 is b to the 17. All right, and this one, so we have -18, a to the 4, b to the 5 over 2, and then everything is raised to the -1. So if everything is raised to the -1, we can just flip the numerator and denominator and say 2 to the -18, a to the 4, b to the 5, and raise it to the power of +1. And then all we have to do is just simplify 2 over -18 is just going to give us 1 over -9, a to the 4th, b to the 5th, and that's it. So this looks a lot more complicated than it really is. And that's it. Okay, so that was just a basic overview of exponents. The next ones I'll do basic overview of logs, and then I'll do exponential functions and logarithmic functions as well. All right, see you guys next time.
Little baby.